Let's talk about how to convert decimal integers to octal integers. For easy understanding, I have a script for you. So let's go through the script. To convert a decimal integer to octal, you need to divide the decimal number successively by 8, and after each division, record the remainder, which will either be 0 or R, where R is between 0 and 1, 0 and 8. The process is terminated when the result of the division is 0 remainder R again. Then, to get your final result, read the remainders from the bottom all the way upward. That is from the last remainder all the way upward. If the grammar seems too complicated for you, let's consider an example. Maybe with that, you can understand the concept. For instance, let's assume we are to convert 8,461 in base 10 all the way to base 8. If you haven't watched my video that I created on how to convert decimal integers to binary, consider watching it, as that can give you a clue on this concept. And also, it can always give you the basic idea behind converting from decimal to another base. So first, we will need to draw a table that will consist of just 2 columns. So at the, well, this is too close. Let me bring it down a little bit. At the left hand side of the table, you have the divisor, which is 8. And at the right hand side, you have the value, which is divided, which is 8,461. Now we can begin the division process. In how many different ways can we have 8 in 8,461? It turns out that it's going to be 1,057 ways. So it remains 5. So as you can see, the remainder will not be up to 8. It will be within 0 all the way to 7. Now I need to repeat this process again. How many different ways can I have 8 in 1057? Because I haven't get to a position whereby I have 0, remainder 1, 2, and so on. That's when I need to stop. I'm still having a very larger value. So I'm going to use my calculator. I can have 8 in 132 places. Then the remainder 1. And again, I'm going to repeat the process. In how many different ways can I have 8 in 132? I can have it in 16 different ways. And it's going to remain 4. And for the last one, I can have 8 in 16 in 2 different ways. And this is going to remain 0. So now, I can see that 2 is less than 8, the divisor that I'm having left over. So I'm going to repeat the process one more time. 8 in 2 is impossible, that's 0, and it's going to remain 2. So this is my final process, because I have a 0, I now have 0 remainder 2, which is within the range of R. So what I just want you to know is that once you get to a point whereby the divisor is now more than the divided, it can be 2, it can be 7, it can be anything, then just know that your result is going to be 0 remainder that divided, maybe 2, 3, or whatever it is. Then you stop your process of dividing at that point. Now let's read our final result to have the conclusion. So therefore, 8,461 in base 10 correspond to, I'm starting from the lower or the last remainder all the way upward. That's 20415 in base 8. And this is my final answer. Number 2, let's consider more problems in order to develop your ability in this concept. So assuming we have 4,261 in base 8, and we are willing to convert this to, in base 10 rather. I wanted to convert this to base 8. So just like before, the first thing we are going to consider doing is to draw a table. So at the left hand side of the table, we have the divisor, And the right hand side, we have the divided 4261. Now we can begin the division process. Now, in how many different ways can we have 8 in 4261? Since 4261 is a very larger number, and to keep this video short, I'm going to consider using my calculator. So I'm going to type in 4261 divided by 8. So I have 532. 532. So to get the remainder, this gives me a decimal number, 532.625. So what I'm going to do is to take the 0.625 and multiply it by the divisor in order to have the remainder. So it's 0.625 multiplied by 8 is equal to 5. So therefore, the remainder will simply be 5. So I can repeat this process again since 532 is more than 8. So in how many different ways can we have 8 in 532? 532 divided by 8 result in 66, and the remainder is this. So it gives me a decimal point as 0.5. So I'm going to take 0.5 and multiply it with 8. So the remainder is going to be 4. Since 66 is more than 8, I'm going to repeat it one more time and I have 66 divided by 8. So it gives me 8. And to have the remainder, I need to take the decimal point after 8. And that decimal point is 0.25. So 0.25 multiplied by the divisor, which is 8, will result in 2. So I have the remainder to be 2. And again, I will repeat it again since 8 is equal to 8. They can divide one another and have 1 remainder 0. The remainder will be 0 here. And 8 in 1 will simply be 0 since 1 is less than 8. And the remainder will be this back. You understand? I think I've explained that earlier. So now, to read my final result, what I'm going to do is to start from the last remainder and read all the way upward. And that will be my final result. So therefore, 4,261 in base 10 correspond to 10,000 and okay, that's 10,245 in base 8. So this is the final solution to this problem as well. So that is it, and that's how to easily and mentally convert decimal integers to octal integers. Hopefully you find this helpful. If you haven't subscribed, please do wait to subscribe to my channel. Thanks for watching. See you guys in the next video. However, I have an exercise for you, and here it is. So let me just write this here. You have to convert 11436 in base 10. That's 11,436 to octal. Comment your solution in the comment section below for review. I'm going to let you know if the answer is right or not. Thanks for watching once again. See you guys in the next video.